Okay, so we're now working on a challenge called Caesar Tart, and it says my friend sent me a message with a flag inside. More importantly, it also speaks about apple tarts. To test your dedication about apple tarts, I made a fancy Caesar cipher to encrypt it, retrieve the flag, and hail the tarts. And it says Caesar Tart, so this might be an indication that it is a Caesar cipher. So let's take a look at the Caesar Tart.py file. So let's see what this file does. So when you open it, it imports random from random, and it opens the message.txt, and message.txt is the flag. So, and then yeah, message is just message, and this function Caesar, it takes a, which is the plain text, and then it shifts it, and key is the amount of times it shifts it. So this does a Caesar cipher shift, and the keys are random numbers from between 0 and 25, and how many times they are generated are random. So it might be generated 6 times. The number of times they are generated are between the values of 5 and 10. So it might be generated 5, 6, 7, 8, 9, 10 times of numbers that are between 0 and 25. And then this enc variable, it's a list, and then yeah, so for IC in enumerate message, it just yeah, first of all we need to figure out what IC means. So let's go to Python 3, and then let's just say a sample message is fake flags. Alright, and then let's look for IC in enumerate message, print I, and then C, and then it just does it. So what C is the position of the letters. So I is in position 0. C is the first letter. No, C is the second letter, but it starts from 0, so it's 0, 1, 2, 3, 4, 5, 6. And then C is the letter itself. So for IC in enumerate message, C is the letter, so it does a Caesar shift on C, and it gets a key by going to the keys list, and the index will be I, which is the position of the letter modulus the length of the key. So maybe C will be I, and then I will be 0 modulus the length of the keys. So how many keys, and then that will be the index of the keys. So for every letter in the message, it will do this, and then it appends it to this enc list, and it joins it. So maybe this is a Caesar cipher because it shifts and rotates the letters. So maybe we can go to a Caesar cipher decryptor like raw13 or something and get something out of it. So let's go to CyberChef, and taking a while to load. So let's go to raw13 because that's a Caesar cipher, and then let's rotate it. And as we're rotating, we don't really see a flag popping up. So, that's very weird. So maybe it's not a Caesar cipher. Maybe we got this wrong. Maybe we did something wrong. So, let's figure out what category or what type this cipher belongs to. So, this cipher is shifts letters. So maybe it's a shift cipher, a type or a variant of a Caesar cipher. So let's look up the shift cipher. So shift ciphers on Google. And so it says shift cipher Caesar variants. Let's check out the page on decode.fr, and it goes to decode.fr/shift cipher, and let's read the FAQ here. So it says it uses cipher encryption and shifts the position of its letters. So it can be shifted by X. So this like a Caesar cipher. So let's read down here. So it says a single shift, all letters are shifted by the same value, is called a Caesar cipher, Caesar code. And we see here in this code, they are not shifted by the same value. You see that they're shifted by random numbers and random values. So it's definitely not a Caesar cipher. So and then when we go down here, it says a multiple shift according to a sequence or a key that is repeated. The letters are shifted from each of the key status. It's called a Wigner cipher. So it says it is repeated. The letters are shifted from each of the key values. So like it might mean that the flag, the letters are shifted from each of the key values. So maybe the first letter is shifted by 1, the second letter is shifted by 3. So we have something like that here. So we might consider this Caesar Tart cipher to be a Wigner cipher. So let's click on this page and let's try to brute force decode using automation tool, brute force decode this ciphertext. So let's put it here, and then let's say let's use automatic decryption. And then when we maybe this is the right one, so just let's see it. So yeah, so at the end it says zero flag ICTF, more like Wigner Tart. So yeah, at the end of the message we get the flag more like Wigner Tart. So let's DM the bot our flag. So the flag so right here it says all caps underscore. So yeah, so these are all caps and they don't have an underscore. So let's submit it, and we have just solved the Caesar Tart CTF challenge. And let's go to CTF challenge solves, and we see that we've just solved yet another challenge.